Hi and greetings. My name is Ainur Shahada binti Abdul Shukur with student ID is 2019219112. Our project code is P40M22 and our supervisor is Mrs. Noliana binti Muhammad Lip. Welcome to our FYP presentation to our panel and the viewers. So today we will present the FYP, that is rainfall forecasting model using univariate techniques. So here is group members. First, starting with the leader, Ainur Shahada binti Abdul Shukur. Second is Nur Hafiza Afzan binti Hassan and Zamria binti Awaluddin. So here is table of content that we will present after this. So we will present the background of study, problem statement, objective, significance of study, scope and limitations, theory exponential, methodology, implementation, results, conclusions, and recommendations. First, let's begin with background of the study. Rainwater is an essential source of nutrition for all living things on Earth, including humans, animals, and plants. According to Neil and Mamani 2009, rainfall happened at a specific time, and there is a correlation between the prior and subsequent data. Therefore, time series analysis is the ideal method for analyzing the rainfall data. Next, based on the Masin ETL 2012, state that a rainfall crisis occurred in Al-Stakada, causing the water level in its major rivers to rise dramatically, which was exacerbated by the high tide phenomenon. This anticipated result in a heavy flood caused by unusually heavy downpour that lasted several days. Lastly, in this study, three techniques will be used to determine the appropriate model and to forecast the future value of rainfall data in Kelantan, Malaysia. Next, I will proceed to the problem statement. We have three problem statements, which are: rainfall is important in controlling the reservoir's water level since it influences the reservoir's water capacities. Heavy rainfall in Kelantan, Malaysia will lead to natural disasters such as flood by Syari 2016. Second, heavy rainfall upstream can cause a rise in the water level downstream. For example, the change in the physical environment of upstream area, such as land use and soil erosions. Third, various mathematical methods also contributing to the existing problem that used to predict and control floods. In Indonesia, mathematical models for rainfall prediction that are currently being established and implemented have not shown the satisfactory result. By Paulina 2017. Thus, it's very important to find a suitable method to predict the future amount of rainfall to prevent and help forecasting using univariate modeling techniques such as single exponential smoothing, double exponential smoothing, and Holt method. Next, I will proceed to the objective. The objective of this study are as follows. First, we want to model a mathematical equation of rainfall in Kelantan, specifically by using univariate techniques. Second, we want to identify the best model in univariate techniques by comparing the root mean square error, RMSE, mean square error, MSE, and mean absolute percentage error, MAPE. And third, we want to measure the forecast value of the Kelantan rainfall model for a year ahead based on the selected best model of univariate techniques. Next, we have significance of the study. The study is to simulate rainfall process so that they can be observed and implemented with suitable solutions. Next, it may be helpful to a meteorologist who want to know which model to use to establish flood control policy during the rainy seasons. Lastly, it helps in the understanding of past behavior in predicting future behavior, as it enables us to predict or forecast the behavior of the phenomenon in future, which is very essential for rainfall forecasting.
Assalamualaikum, my name is Zamria binti Awaluddin, my student ID 2019253746. There are three parts that I will present, which are scope and limitation, theory exponential smoothing, and methodology. Okay, now let's moving to scope and limitation of this project. The purpose of this project is to identify the monthly rainfall pattern in Kelantan within 7 years that provide and improve and efficient rainfalls forecasting system. Second, the primary aim of this project coursework is to obtain the maximum accuracy of the predicted rainfall in Kelantan. The last scope is the software that will be used for this project is Microsoft Excel. Next is limitation of this project. The study was only involved conducting in a specific country in Malaysia, which is Kelantan. The next one is small and limited sample data is taken to determine the accuracy of the performance and pattern of the rainfall. Next part I will present is theory exponential smoothing. The first one is single exponential smoothing, also called simple exponential smoothing. Is a series forecasting method that has been used for univariate data without a trend or seasonality. As we can see from the equation of single exponential smoothing, alpha here is called a smoothing factor and set to value between 0 until 1. The advantage of single exponential smoothing are simpler than other forms and require limited data, while the disadvantage are lagging actual data and no trend or seasonality. For double exponential smoothing is practical for series that display linear trend characteristic. The main advantage of double exponential smoothing is its ability to generate multiple ahead forecasts. The last theory of exponential smoothing is Holt method. Holt method is an essential of single exponential smoothing that enables pattern of data. This method consists two parameters which are alpha and beta for level and trend, and the value is between 0 and 1. The last part of my presentation is methodology. This study starts by collecting secondary data on rainfall in Malaysia from the Malaysian Meteorological Department and use it from January 2014 to December 2020. After that, the data is used to fit the methods, that's performance evaluation and comparison between the method to select the best model. In this study, the procedure of fitting univariate technique rainfall model in Kelantan, which are evaluating the performance of exponential smoothing and forecasting the rainfall model using the best exponential smoothing. That's all from me. Thank you.
Assalamualaikum. My name is Nohafza Afzan binti Hassan and my student ID is 2019218366. I will continue to present about this topic with the implementation, result and the conclusion. For the implementation, firstly we start to assume an initial smooth or startup value for alpha. We choose to start with any random value of alpha. Then we calculate the estimated or smooth values. Thirdly, we calculate the error. Then we proceed to calculate the mean squared error. And then we calculate the different values of mean squared error. Then we find the best alpha value, which consider the smallest value of mean squared error for single exponential smoothing and double exponential smoothing. Meanwhile, we find the best alpha and beta value, which produce the lowest mean squared error. Here are the fitted equation for each exponential smoothing based on the best alpha with the smallest value of mean squared error. For the result, the value of root mean square error and mean square error of single exponential smoothing in training period and validation period are the lowest compared to double exponential smoothing and Holt's method. Meanwhile, the value of mean absolute percentage error of Holt's method in both training and validation period is the lowest compared to single exponential smoothing and double exponential smoothing. Hence,
we conclude that the single exponential smoothing is the most effective approach among double exponential smoothing and Holt's method, since it uses the lowest value of root mean square error and mean squared error. For the result of forecasting, we forecast the rainfall model in Kelantan a year ahead using the best selected univariate technique modeling, which is single exponential smoothing, as it has the lowest value of root mean square error and mean squared error in the training period and the validation period compared to the double exponential smoothing and Holt's method. So, the forecast value of the rainfall intensity model in Kelantan is the highest in December, since the graph shows an increase in rainfall starting from January up until December due to northeast monsoon. The rainfall intensity is characterized as heavy rain lasting 2 to 5 days, windy and cooler conditions. Hence, based on the lowest error in the training period and validation period, single exponential smoothing is employed to forecast the rainfall in Kelantan. Next, for the conclusion, our first objective that has been achieved is to model a mathematical equation of rainfall model in Kelantan using univariate modeling techniques, which are single exponential smoothing, double exponential smoothing, and Holt's method. For this part, we are able to find the best alpha for single exponential smoothing and double exponential smoothing and the best alpha and beta for Holt's method. We are also able to provide the mathematical equation that can be used for forecasting for each exponential smoothing based on the best alpha and beta. The next objective that is achieved is analyzing and comparing the performance of the three univariate modeling techniques by several error measures, namely root mean square error (RMSE), mean squared error (MSE), and mean absolute percentage error (MAPE). To conclude, single exponential smoothing has the best performance as it produces the lowest value of root mean square error and mean squared error in the both training and validation period. So, it can be concluded that single exponential smoothing is the best model to forecast the future rainfall intensity model in Kelantan for a year ahead. Finally, the study is conducted to forecast the rainfall intensity in Kelantan using the best model, which are single exponential smoothing. The single exponential smoothing model is suitable for forecasting as it takes into account the most recent forecast and it requires the retention of only a limited amount of data. There is no need to store data for many periods.
Last but not least, for the recommendation, it's shown that the single exponential smoothing shown as the best model to forecast the rainfall intensity with the best smoothing parameter and had the lowest root mean square error (RMSE). Next, Bose-Jenkins can be applied in evaluating and estimating the current data. Despite the accuracy of the Bose-Jenkins methods can be considered good, valid, and satisfactory, and despite that the projected values are classified as a reliable forecast. Lastly, machine learning models can be used to obtain the most accurate method for predicting the value of rainfall with data patterns such as this study, or developing the toolkits to facilitate predicting the rainfall intensity by evolving network security. That's all from us. Thank you.